screen now.
Okay. So hi everyone. So again, my name is Patrick Chesam. For the most part, I would like to think that I'm a full stack engineer, also by experience and based on some of the things I've done in the past. Um, so today we're going to be speaking about microservice architecture, right? Before we even deep dive in, there's this whole buzz about microservices. But in my head, I'm like, maybe we should even set the ground rolling by talking about why microservices are really important to modern day software engineering as a whole, right? Because apparently that buzzword has come to stay. A lot of applications today are running on this architecture as the case is. So, I mean, something we should even understand why it's necessary. Um, so it's become like a very significant and transformative process, right? And in modern technology, as opposed to, so you always hear two words, right, concurrently spoken with each other when it comes to this type of activity. Can you guys hear me?
Yeah, we can hear you.
Okay, so you always hear like monolith and you always hear microservices. I don't know if anyone has an idea of what a monolith is. You want to share? And by the way, feel free to raise your hand up if you have a question. So, well, a monolith is just what it is, right? Think of it as a system where everything you needed to do to make that system work is just packaged as one single, one single code base, one single deployment, one single architecture, one single business logic that just encapsulates everything, no separation, tightly coupled with each other, right? Again, we'll get to know what tightly and loosely coupling stuff is. So literally you have a system that, for example, if there is an issue and it goes down, literally every part of the system just goes down, right? That's what you typically get in a monolith architecture. Well, again, it has its advantages, right? Um, but and some smart guys somewhere thought about the concept of microservices. And again, for a couple of reasons, right? I'll touch on a few. Scalability, right? That's very key when it comes to microservices. This means that that whole big monolith application, right, that typically has everything you would do. For this scenario, let's just base our understanding on maybe an e-commerce application, right? It has a login system, probably has an ordering system, it has a checkout system, it has a loyalty management system, etc. Typically in a monolith system, right, it's you're unable to scale parts of this system, even though they are independent business logic, right? But with microservices, you get this scalability where every item is broken into separate chunks that communicate with each other, right? Um, so I think I'm sharing my whole screen, by the way, right? So can someone let me know if you can see both the slides and this diagram
You
window I have open?
can see.
I can see
Oh,
only the slides.
okay, you guys can see only the slides. Okay. So for now, let me share my whole screen so I can just move between windows. So yeah, so you can see between windows, right?
Yeah, we can see them.
Okay, awesome. So I just have this here just in case we needed to draw some diagrams and we can see things more clearly. So let's imagine that you have a system, a monolith system like this, right? Where you have like the login, you have like the order system. Let's say you have like the card system, you have a loyalty system, for example, and all of this just makes up like an e-commerce product, right? Let's just base this on e-commerce. But with microservices now, right? Again, it's a no-brainer, right? So we're going to break this into different chunks. We have our login here, right? And we have our order, right? We have our cart, and we have our loyalty system. Let me just even call this e-commerce monolith. I hope my screen is visible enough.
Yeah, this is
Okay, cool.
Yes, it is.
This, okay, nice. Microservices. Okay, so I mean this kind of like says it all, right? Again, there are like micro chunks of these whole different modules. It could be grouped by a couple of things. You could group it by the business decisions, right? What that means is it could be domain driven by the business decisions. So the business might say, oh, we want to have this section like this. So you might have to implement a service that typically speaks to that. Or it could be by an application feature breakdown where we can say, okay, can we break the services based on what the application is even doing? For example, let's make login very separate and independent. So some of the things you find, right, now that we've been able to sort of represent it in in actual images, is that this guy is easy to scale, right? Since they are broken down into smaller chunks, right? We can allocate, what that means is we can allocate separate resources to each of them individually, right? As opposed to always doing this on one system. So we might see that, oh, we get more orders, right, than we get logins. So we're probably getting like 2 million hits per second, for example, on orders. And on login, we're getting maybe like 1,000 per second. So what that means is that we can easily just scale only this service while other parts of the system remain the same, right? And flexibility, of course, because because these systems are kind of like independent, it's easy to just make updates, for example, on separate parts of the system, as opposed to just doing it on one system, right? And then resilience, you see things like resilience coming into play. Every system can implement its own separate system for keeping itself alive, as the case is, and bringing itself up again. Separation of concerns is very key here. And if because our systems are broken down into simple chunks, right, it's easy for you to maintain and test the system. Because one of the things you will notice when building very large enterprise applications is there is a whole lot of moving parts, right? And if you don't test your application well, you land into problems, of course, in production. But the problem with monolith is, imagine where you had a situation where maybe your QA just missed one bit of check and the application is just running, is good. And then one user somewhere just goes to that part that the QA missed. And then boom, there is a bug on the application, right? Typically, what you find in the monolith system is that everything just goes down, boom, until that bug has been fixed, right? But one of the other key advantages, which I'm talking about in testing and maintenance, is that if for any reason there is a bug, right, it's mostly going to be self-contained in that component and will not literally bring the whole system down. So at least people will still be able to, add stuff to their cart, still get their loyalty system. And let's say the other service is down, and then we try to fix, some of the issues here as the cases. And then, like, of course, I've talked about a couple concepts, isolation of concerns. Every guy is just tuned to what he should be doing, right? It's easy to scale it, and it's easy to just deploy this. And one of the interesting bits about deployment is that most times these guys can be deployed on, they can be deployed on separate servers and we'll all be fine, right? They could be deployed in different regions and everybody will be fine as far as they can discover each other, right? So again, these are just the few benefits we have, right? And I could go on and on. But I felt like it would be key to just look at these guys together and see what they give us in a simple system and really start the process by thinking about why we even need to, go through microservice architecture. So let me stop and ask questions, guys.
Please, I have a
Any
question.
question for me? Yes, please.
Um, Good afternoon. Please, I just want to ask, making a practical or realistic example using, let's say, Amazon websites. And I would just like you to give an example of microservices on Amazon websites. Like, where can it happen? Like, for example, someone is shopping, I'm shopping, and something goes down, something realistic so that the picture stays in my head, or just an example. I don't know if I explained myself right.
Okay. So let me give you a typical scenario, right?
Yes, it's
Let's say that this our service is our makeshift Amazon, let's say makeshift Amazon website, and we want to just do a simple thing like just purchase a book, right? Ideally, we have to navigate to the website, right? And for us to, I will just add another container here, and I'll call this website, right? So this is the guy here, right? This guy is our actor. Sorry. How do I move in? Yes. So this guy sends a request here to the website, right? And I mean, of course, you see the web. So you know that whenever you enter the URL on your browser, right, you're typically sending a GET request somewhere to pull a couple of HTML pages for you, right?
Yes.
So this guy sends a request here, pulls a couple of pages, he sees it, he sees what he wants to buy, right? Ideally, the next thing you have to do is sign in or sign up, right, as a user to buy something. So let's say at that point, this guy calls this guy, right, to sign in.
Yeah.
So I have a thing with.
No, we understand. It's dry.
Okay, nice. So this guy calls this service to log in. So what you typically see is, let's just assume that this is where our bug is, right, in the other system, right? So let's just assume that this is where our bug is. But we can see that here we're able to go into the website. We have no issues, right? These guys are not being activated, right? So one of the cool things about microservices is that they have a system of communication, right? So one guy calls one guy, typically, they communicate via APIs, which we'll go into. But when you think about it, there is a method of communication and there is a response to that communication, right? When a service is activated. So you log in, no issues. You add your items to the cart, you have no issues. And maybe you were using like a promo code, right? And you make a request to just activate a promo code. Your loyalty system is, activated, and that works. And let's say when you go to checkout, right? When you go to checkout, there is an issue. We can't check out, right? Typically, what you might see is that before you even get to that point, all of this data kind of like sits somewhere. So this is why it's so easy for you to know where the user left off, right? As opposed to if it was one whole system and maybe that data was not being saved accurately by each guy. So it breaks down. You can't order, but you can save your order and come back again, probably some other time, and then you can see your order and you can proceed to check out, right? Even if there was a bug that made this guy break and this service totally went down and it won't come up again, you still be able to go back to your website, right? You still be able to log in. You still be able to add more items to the cart and save it for later. As opposed to one whole system where you have to get someone to either bring the system up again and then write some codes on the go to prevent you from even going to that component that is failing. Because every time someone tries that, the whole thing drops again, right? So I don't know if I've been able to touch on your question.
Yes, you did.
Um,
You
so-
did. And yes, it's the pictorial example would stay in my head longer, and I'll be able to transfer the knowledge to any other kind of situation. So yes, thank you.
Absolutely, absolutely. So again, that's why I have this guy on the side, right? As we move through the slides. Okay. So
Yeah, I
what's
have
the
a question.
microservice architecture? Okay.
Can I ask a question, please?
Yeah, so let's go. So it depends. If I'm going to, so the trick is that if I'm going to touch on that question in a bit, I'll just like let you know, and then we can flow through the because I reckon some of the questions we might answer them as we move through the presentation. Okay.
So no, it's based on the logins. For example, now, if a user has never logged in the e-commerce site before and he wants to log in and there is a bug in the login, so how can you figure out this?
Okay, nice. So we're going to go into something cool about microservices we call observability and monitoring, right? So it's a way for us to on the go know what is happening, right? Because you don't want, so the idea is that, well, some things might be inevitable, like someone not checking the code properly, and then there is a bug in production. It's inevitable, right? But you don't want a situation where the new architecture you're bringing to solve a problem is actually, not solving that problem per se. If the entry point is at your login, definitely you'll not be able to do any other thing, right? Because you can't log in. But these are some of the things that are solved with proper observability, application monitoring. So you always know when things break, right? So we'll get to that as we speak. Okay, so the whole microservice architecture is an approach to designing and building software applications as a collection of loosely coupled. So let's keep some terms in mind. Loosely coupled is something you should keep in mind. Independently deployable services. In this
Hello? Oh, it's not from mine. We can't hear you.
Yes.
Yes.
we lost
Yes. Let's just give him a few minutes. I think he's having issues with his network. Hi, Patrick. Hello, Patrick. Your mic is muted. You are talking.
Yeah, so I
Okay.
think my screen went off. I was trying to share again. Can you guys hear me now?
Yes, it's fine.
Okay, so I'll just shoot and let's talk about some of the key concepts, right? When we talk about microservices. So the first thing we want to consider is the composition, right? This refers to the process of breaking down a monolithic or complex software application into smaller, more manageable services. The goal is to divide the functionality of the application into discrete components for specific business function, right? So let's look at this simple example I did. And we have this whole monolith system. Right now, we just did a decomposition and we're like, okay, let's break this system into specific chunks, right? That can handle specific things. So one of the cool things to note, right, during decomposition is you have to think about functions as solely independent, because that's the whole idea of a microservice. It has to function solely independent and make its decisions, right? Even though we'll get to talk about some things like data storage where you can share like data storage in some instances, but for the most part its logic and everything it offers has to be independent. Okay, So we have that next, of course, a fundamental principle of microservices. Each service should be self-contained and autonomous. This means that it has its own database or data store and can be developed, deployed, and scaled independently of other services. Independence allows development teams to work on different services concurrently without impacting each other. So one of the cool things we need to note here is that microservices alone doesn't just stop at the technological advantages it gives us. It also comes into like the team advantages, right? So we can have like separate product teams work on separate items here. Now, the cool part is we could decide to build our loyalty system, for example, in Java, and we could use like MySQL for it. And we could come to our cart and be like, well, since our cart, we need it, we don't care about how fast it is. We just want to perform a lot of AI algorithms. Let's build it with Python. And then we were like, okay, that makes sense. And then you come to your order and you're like, well, this guy will be taking a lot of, requests per second. So let's build it with Node.js so it's faster. So in a microservice architecture, right, it gives you that separation of consent too for your stack, where every service can choose to implement a different stack, right? As long as they can communicate with each other, we're fine. We don't care how you actually do it. Think of it like input output. As long as you get an imputed data and you export an outputted data, then it doesn't matter how you do it within yourself. So that means that you can have separate teams, separate people working on this, right, with minimal idea of what is going on in other guys. Some of the things, and this is because, note, this is because there are specific APIs for these guys to communicate with each other, as opposed to a tightly coupled system. What you find here is you might have to study how each of the codes work to even make a change. So I think someone has a question. Okay. Oh, okay. Cool. So communication, right? In a microservice architecture, services need to communicate with each other to perform complex tasks. There are various patterns and protocols, including RESTful APIs, messaging, gRPC, GraphQL, right? So you might now ask yourself, well, if we're independent, right, how do we communicate with each other, right? So I'm just going to, let me do something, and let me just call this protocol. So let's see, we have REST, gRPC, let's see, we have messaging, and we have like GraphQL. By the way, question for you guys. Are you guys familiar with some of these protocols? Anyone? Okay. So think of it like every guy in this chain, right? Okay. Sorry, can you guys hear me? Just checking.
Yes.
Yes, we can.
Okay. Okay, cool. So every guy in this whole circle, right, has to communicate. By the way, forget these arrows. They are both like inbound and outbound arrows, right? So it goes both ways. But the idea here is that these guys need to communicate one way or the other to know when something happens, right? Because I mean, every system is sort of like driven by something, an event, an action. Whether it's taken by a user or it reflects action to another action, but something has to be an entry point for these guys, and they need to know when to speak to each other. So there are a couple protocols, right, that you could implement for your services. And there is a reason why these guys exist. I have a question for you all, right? Because so far so good. All my questions, nobody has attempted to answer. So I would like if someone attempted this, right? What is the common thing to all of these protocols? I mean, because they all look like REST, gRPC, messaging, GraphQL. But what is that one thing that is common to all of them that makes it easy for each of these guys to interpret that message? Any idea? I'm trying to not be too obvious.
Okay, I think they all work with a common API that they get to connect with each other. There's a communication flow between each of them.
Okay, fair enough. I want someone else to try. I'm looking for a particular word. Okay, so I'll just give you the answer. Underline, right? Apart from like RPC, which includes which implements a sort of proto file that defines a message buffer, right? You notice that they leverage on standards like JSON or RPC, right, for communication, because everybody understands JSON at the end of the day. And whenever you implement a protocol buffer, you also define the standard that everybody understands. So the idea is that, well, even though we're independent, we need to have a common standardized way where we speak to each other. And I know what you're sending to me, and you know how to package that thing for me. So you see technologies resorting to JSON and proto files for RPC definitions. So yeah, that's key to note. So REST here will involve like API calls. gRPC, of course, involves like RPC calls. Something to note about messaging, which is very cool, which I will touch on a bit. Is that a question for me? Yes. Oh, someone answered it. Well, yeah. So in the messaging system, right, we always have two parties, of course. So you could call one a publisher and you could call the other guy a subscriber, right? So for messaging system, you rely on a middleman who is always called a message broker, right? So this middleman who is called a message broker sort of does two things for you in summary. It's able to know that someone published something somewhere, and it's able to know who is waiting for that response on the other side, right? So let's do that with a simple diagram. So because I want to touch a bit more on message broker. So let's say this guy. By the way, I hope the diagrams are doing justice to some of these things, guys.
Yes,
Yeah, it is.
Okay. So some people might call it subscribe. Sorry for my English. Some people might call it consume. And some people might also call it produce, but they're actually the same thing. So let's say this guy are all components of this guy up here. So what would typically happen is that okay. So what would typically happen is that let's say that you successfully logged in into this application, right? And when you log into the application, it's meant to sort of go pick your cart so that you can see all the items you have in your cart. That's an arbitrary example, right? And in this scenario, we're like, you know what, when this guy successfully logs in, how can we just pull up his cart for him? So the action here is very simple: successful login, and the event, sorry, is very simple, which is a successful login. And the action to be carried out is load up the cart. So typically what this login guy would do, right, he will just come and maybe publish, let's call this he will come here to his message broker. That's if we're using a message broker example, which I will explain further. And then he will say login successful. And this guy is going to be on this subscribe bit. Oh, my arrows are no more making sense. So let's do it from here. Okay. Okay, nice. So what would typically happen is that in a message broker system, you always have a guy who publishes an event and a guy who subscribes or consumes to that event. So when an action happens, when an event happens, it sends a trigger to a publish instance that listens for when someone has published stuff. And how this guy will know is very simple. They always have the same identifier. So this guy will be listening to an identifier here on the subscribe bit that is being activated when a message is published, right? So in this system, you can see how systems communicate with each other using a middleman called a message broker. So when an event happens, it triggers a publish or a produce. Sorry, this is meant to be produced. Where an action event is produced for someone to pick it up, right? Sort of like, well, I sent a message. Can you notify the person that needs to get this message? And the person that needs to get the message must be listening on something for that message to come in. So yeah, very cool, right? Some of the systems you find in place for this are like, you've probably heard of Kafka. I don't know if anyone here has heard of Kafka, RabbitMQ, ActiveMQ, maybe AWS simple queues. You also have examples, even Redis, right, can help you achieve this type of message broker system. And then you have GraphQL. So GraphQL is very cool, mostly built on top of RPC. It just really helps us as a client write our queries better. And so at that point, right, well, we're not going to talk about GraphQL anyways, but just so you know, this is also a method of communication, right? Yeah, so let's move on. So yeah, we talked about a couple things, right? And we touched about some of the characteristics of a microservice. First of all, scalability is very key, right? Scalability is the ability of a system to handle increased load by adding more resources. Microservices enable scalability through horizontal scaling, which means adding more instances of a service to distribute the load. Key aspects of microservices that facilitate scalability include service isolation, which means that every microservice is self-contained and can be scaled independently. Load balancing, traffic can be distributed evenly among multiple instances of a microservice. Elasticity, microservices can be designed to automatically scale in response to changes in demand. Microservices statelessness, which is just an ability for microservices to scale because they don't store session-specific data, which is very key. One of the things you will find is that because these services are sort of like independent, don't forget that bit, very key, sort of independent always, you always notice that it's easy to do specific things with them. And they have a way of managing their own data internally. So you don't have to save a session, right? So because it is stateless, it's very easy to just create multiple instances. So multiple instances of a service just simply means increasing the, well, I mean, you could just term it a simple way of just making that service available, right? More than one to anybody who requires it. So imagine that we had a login here, right? Or let's say our cat. Creating an instance of cat is just as simple as replicating that service running. So now we have two cats running. and we have one login, one order, one loyalty system, one website, as opposed to this guy, right? If we wanted to scale this guy, we literally have to do all of this. So you can see the difference when you try to scale this guy, right? But so you can see the difference. You're literally doing the same thing on the whole system. I mean, you don't want to even think about the cost, right? Because I mean, these services are expensive. Running requests very expensive, especially if they are cloud services, right? You don't want to see your bill. So, but yeah, we can see that, well, we just want to have 3 instances of the order running, and that's fine. We can do that, and our system just scales horizontally, right? Cool. And then one of the other characteristics you always see is load balancing, so that all of the requests that comes in, if there are multiple guys trying to send a request, will always be balanced across these 3 guys. So no one is overworking themselves, right? That way you have a more resilient system. And because each of them are saving their data independently, so it's stateless. That's one of the cool things to note about microservices. They are stateless. So what that means is that it has to find a way to get the information it's looking for within itself or within that event that called it. It's as simple as that, right? Think of it like REST services. Of course, APIs, REST APIs are stateless, right? That's why you always use a token when you want to make an authenticated request. But the idea is that every call is stateless. So it has to find the information it's looking for within itself or within the contained message for that event. All right. So we talked about resilience, right? The capacity of a system to continue functioning despite faults, failures or faults. So one of the cool things I forgot to mention is that there's also the characteristics of microservices to downscale. So let's see that, well, we're not getting a lot of requests on the order. We don't really need 3 instances running. We just need 2. So it automatically scales back to horizontally, both upward and downward, right? So redundancy, running multiple instances of the same service or using multiple services that provide similar functionality helps ensure continued service availability in case of failures. Circuit breakers, implementing circuit breaker patterns helps preventing cascading failures. When a service experiences issues, the circuit breaker can temporarily stop sending requests to it, allowing it to recover. So one of the cool things to also note here is that you could implement a sort of service circuit breaker system where, imagine that the login was trying to send a message to the order and this guy is down. So we could implement a system that were like, well, if we tried sending this request 10 times in 10 minutes and this guy doesn't respond, then we know that something is definitely wrong with it, right? So we will give it time to recover and try again in like X time. And in the moment, we can probably just, keep an error log so that when the guy comes back, he knows that, oh, these things happened, right? So with microservice architecture, you can also see that circuit breakers go a lot to help how information is being collated, how errors are being logged, how a service responds to another service if it's not up and running, right? So these are key concepts you need to keep in mind. Then monitoring and logging, of course. So we'll get to that bit, right? We'll get to that bit where we talk about, well, if we have a very complex system like this, again, everything has its own disadvantage, right? I mean, if you look at this other side, it's just one guy as seen that has everything in it. We don't have to worry about a lot of things, but it comes with its own issues. And then you look at this other guy, we now have a slightly more complicated system that gives us the ideal way we should be running, right? So you're like, well, how do we monitor what is going on around this whole ecosystem? Right? Because at the end of the day, we shall need to know what's happening in our application. So we'll get there. So logging and monitoring is a key characteristics of every microservice, or else you end up in a situation where you don't even know where the issue is coming from. And that's the worst problem you want to have at the end of the day, right? All right. So continuous integration, continuous deployment, CI/CD. So one of the other characteristics is just a set of practice of tools for automating development and deployment pipeline, where you have like automated testing, containerization, orchestration, continuous integration, and continuous deployment. So I'll explain. So one of the things you want to have in your microservice, right, is a sort of accurate testing process that will test every guy independently and make sure that every guy is good on his own, right? And you will mostly come across testing like unit tests, which means that this guy as a contained guy is able to write unit tests to determine that the functions is exposing are good and it doesn't have any issue, right? And then you will see something called an integration test, where this guy too has to also connect to a bunch of guys to be able to communicate in that ecosystem, right? So he will typically perform an integration test to be sure that, well, I can integrate to the message broker, for example. I can integrate with the protocol and send messages and receive messages as the case is, right? So this is where these four things come into play. Automated testing, containerization. Have you guys, I mean, most of you guys should be familiar with Docker, right? Is there anyone familiar with Docker? Another buzzword.
Yes, yes, yes.
Okay, nice. So
Okay, I
Docker
have a
just,
little question. Sorry, you
yes,
mentioned unit testing and integration testing.
integration
Okay,
testing. Yes.
yes, based on that, what are the difference like in terms of that? Because most times I see people when running their CI and CD pipeline, they include the integration testing, but no unit testing. So what are the difference and the functions for the two? Like
Okay,
what?
nice. So good question, right? So I will do something. Let me take another guy down here, right? And let's call this guy our login. And well, inside the login, let's say we want to validate email, and let's say we want to validate password, or let's say we want to use Google login or Google authentication. And let's say we want to, navigate to dashboard after successful login, right? So let's say this is all what our login guy does, right? So unit testing this login guy will simply mean that you have to write a specific piece of code that verifies every use case that login guy should do. So you have to write a piece of code that checks that validating an email works. You have to write a piece of code that, for example, checks that validating a password works. So unit testing, as the case is small chunks of your code that actually does a specific thing and can be tested independently, forms a criteria for a unit. And then you have to actually write code to test that unit, right? So again, this is contained within the service. And let's say this guy had to call, and I'll be specific here with this example. Let's say we're using RabbitMQ as our message broker, right? And I'm sticking to message broker because, I mean, we spoke about it earlier. So this guy, right, will also have to do what is called an integration test. And let's say this guy had to also connect to, let's say, MongoDB for data storage, right? So the integration test is basically how this guy connects to all of his dependencies in needs. So it's integrating to them, right? So you write a test case that checks that, okay, I can call RabbitMQ, I can send a message to it and it responds that that message is good. And I can connect to MongoDB and I can, whatever, pick up the user details, and I'm sure that that works. So if you look at it, right, everything in a unit test is just contained to the logic that exists for every testable unit. And integration is sort of like end-to-end that makes sure that all of the dependencies it needs, you can connect to them and get the appropriate feedback it needs, right? So I don't know if I answered your question. Very, very key.
Yeah.
Okay, cool. So of course, it's always good to package best practices, package your services as containers, right? I could have shown you. Okay, I don't have an example running. I wanted to show you an example of applications that have been containerized and running in a cluster. But that would take quite a while. Hopefully in other sessions we'll touch on it. Then continuous integration. So you don't want a process where it's probably taking you a lot of time to make updates to your services, right? Which is where continuous integration and deployment come into play, where we're able to automate our changes from our repository, which we'll talk about later when we talk about version control. For people who are not so clear, you will understand what that means soon. So it's sort of like automating our old development cycle from when the engineer is working on his system to where he pushes his code somewhere to where that code builds and a couple of checks are running through a pipeline and then it's good. And some of the things you will note in the pipeline, like the question he asks is that you could run a test in your pipeline to sort of like automate all the unit tests contained in an individual service, right? Let's say we have a so I need to also close on this soon because time is going. I just realized that. So let's say you have a pipeline, right? So in this pipeline, you could do a bunch of things. You could run all the tests you have in your login. You could run all the tests you have in your order during your continuous integration. And you can say that, well, if all of these things are successful, we've done all our unit testing in each of these services. We've done our integration tests and everything is complete. At the end of this, then initiate a continuous deployment, right? So that at that point, you can unpackage your application and deploy it to wherever you need to, wherever you need to deploy it, right? And thank God for the people we call DevOps engineers. They make life easy for us. And so fun fact, right? I work with Dapo2 every day, and it makes life easy for me in a lot of ways by automating these features. And what's very fascinating to notice, we work with a ton of services, a whole lot of services doing independent things, right? And responding to a lot of requests per second. So the importance of these features cannot be overstated. They need to work, right? Especially when you're working in a rapid development environment where every guy is, because one of the cool things you'll notice is that if we're all distributed across services, this guy can be faster than this guy in doing stuff, right? So you need to always provide a way to continuously provide these changes on the go for each of these independent services, packaging it as one. Yes, nothing comes without challenges, right? And some of the challenges we will see, like I said, is complexity. Before, we just had one guy that was just doing his stuff without issues. And you were like, well, if something happens, it could affect everything. And we're like, well, let's come up with a system that solves our problem. And we came up with this guy that sort of looks very jumbled. So again, I think this just answers what complexity is. So that's one of the challenges you have, right? So some of the things to do, some of the things that are very key when you deal with complexity is documentation. It's always very key to document your architecture. That's why it's called an architecture for a reason. It's a no-brainer that you cannot build a house without having your architect drop something for you that points to what is actually happening. So I mean, documentation is very key to avoid complexities. Separation of concerns also will also avoid complexities, right? When you know that every guy is specific to just doing something. Distributed system challenges. Now, you will notice that all of
Christian,
this represents distributed system, right? All of this represent a distributed system. For example, this guy could be on a different server. Same with this guy, and same with this guy. They could literally reside in separate places, right? And then that might come up with challenges of, well, how do I make them communicate through themselves? Maybe over a firewall, maybe there were some connections with the IP address and with the ports that this guy is meant to listen to. So all of those challenges just come in place. You have to do a ton of configuration, right? Which we'll get to actually make the system work. So yeah, those challenges will always exist. Data management complexity, which is key. The good news is that these guys can save their own data independently. The bad news is that, well, what if the data is not, what's it called? What if the data is not streamlined across all of them? Then you come with a situation where this guy has a different set of data from this guy and this guy and this guy. So again, it's very key to clearly map out your data structure, how you want this information to be saved, and how you want this information to be serialized and deserialized across the microservice architecture, right? Or else you will end up with a lot of data management complexities where data is not streamlined across all of these guys. Yeah, then testing and monitoring challenges. Well, is anyone here familiar with open telemetry? Just asking. Is anyone familiar with it? Okay, so I'll take that as a no. So I think did I add that to my assignment? Okay, I will update it. So with open telemetry, right, we can implement a tracing system across our network, across our architecture to know where issues kind of like happen. So what that means is that from the moment this guy makes a request, right, we're tracking what happened. We know that, well, this guy went to log in, and login went to order, and order went to cart, and it failed when it came back to order, right? So with open telemetry, we can sort of like set a monitoring system to observe how this call moves across the architecture or the services and where an issue happened, and we can implement like health checks. So health check is something else that is really cool. So we can say that, well, anytime a service goes down, can we know about it and can we try to just bring it up again? So these are some of the cool things we will see when we implement microservices. If they are not done properly, you end up having a lot of challenges when it comes to testing and monitoring. All right. So lastly, I will talk about, I'll just use a couple minutes to talk about service discovery. So service discovery and orchestration are essential components of a microservice architecture, helping services find and communicate with each other in a dynamic and distributed environment. So two key concepts here: service discovery, service orchestration. Service discovery is the process by which services within the microservice ecosystem locate and identify each other. in a dynamic and constantly changing environment where services may be added, removed, or scaled up and down dynamically. Manual configuration of service endpoints becomes impractical. Service discovery addresses these challenges by providing a way for services to register their location and discover the location of other services, right? So this is typically a concept that just helps every individual service register their location somewhere and discover the location of other guys, typically using their IP addresses and ports. So it knows where to, or if you're using a message broker, typically what that event is and what that response is. So this has to be registered somewhere. So this guy can discover who he's talking to, right? As the case is. Service orchestration is the process of coordinating and managing the interactions between various microservices to fulfill a specific request or workflow. It involves routing requests, load balancing, handling retries, and managing the flow of data between services. Service orchestration ensures that microservices work together seamlessly to achieve a common goal. So let's say that, and this is the last diagram I'm going to do. Let's say we have this guy, right? And we call this guy proxy, right? And let me just bring back these guys. Just back. I can use 4 of them. Okay. So let's say that in this our proxy, right? Let's say we have login. I'm going to type a bunch of arbitrary things, and we say 127.0.0.1, right? And we say this guy is on, let's say, port 90, right? And let's say we have 91 for other. Right. And let's say this proxy is on 89, right? Let me copy this, our guy again. It's our actor. And let's take this guy here. Okay, cool. And let's say this guy is speaking to login, and this guy is speaking to other, and so on and so forth. So now, service discovery, right, is the process by which services within a microservice locate and identify each other. So let's say that everybody registers where they are under this proxy guy, who is a sole entity that sort of takes the addresses of all of these individual components, and he has it here, right? And then orchestration is a process of coordinating and managing interactions. So this guy also has the ability to send requests to a bunch of guys here, either a login or an order, or maybe an add to cart request or something. But the idea is that this actor will always send a request to one guy, which is 89, where the proxy is, and this proxy orchestrates the request to any of the guys, for example, that needs that particular request. So this is just a bare example of what service discovery and orchestration typically means in simple diagram. One place where everybody registers where they are, and this one guy knows when to call a particular guy or where to route a particular request to, as the case is. So yes, so far so good. There's a lot of concepts we cannot cover in an hour, but I'm hoping that you guys have a good understanding of what a microservice architecture is. So I'm going to stop now and take all of your questions. Yes. All right, guys.
Hi,
I've been
good
talking for
afternoon.
so long. want to hear your voices. Good afternoon.
Yeah, my name is David. So I just want to ask you, you mentioned Docker, right? And I'm kind
Yeah.
of used to implementing Docker on with Tomcat and the likes. But I want to ask if you have
I
idea
can't
of how to
connect to that
implement
machine. Is it
Docker
down?
for WebLogic servers.
Come again.
Yeah, I want to ask if it is possible, or if you have an idea of how we can implement Docker on WebLogic servers. Now we have
Oh,
some,
okay.
yeah, we have some organizations that actually do not use Tomcat for their deployment, to handle deployment, or which I think it would have been quite easy implementing Docker for Tomcat. But now in a case where those organizations don't use Tomcat, they use WebLogic servers to handle their deployments. Is there a possibility of implementing Docker for that kind of situation?
Okay, so for this, I will leave the expert on that to answer. Is that point here?
Okay.
Yeah. Okay. So again, David, this is not a Docker. This is not a Docker class, right? Docker is going to come up by next week. So by the time we
Okay.
get to Docker, right, we should be able to take that, so that at least we can give room for more questions that is targeted towards microservices. Does that help?
Yeah, that's fine. Then my second question also is, we for microservices, we understand that microservices actually help to eliminate the risk of single point of failures, just like you said.
Yep.
Now, yeah.
Mhm.
So, what if now? I don't know if you also talked about gateways, because I joined quite late. Now, if you talk about
API
if you talk
gateways.
about yeah, API gateways, yeah, where the whole microservices actually communicate to, is that not also a single point of failure? Considering the fact that if that API gateway fails, what happens? Is there a way? Is there a way to eliminate that risk for API gateway failing?
Well, again, if you think about it, right, like I said, at the end of the day, you have the risks and the reward, right? The goal is there is always going to be some certain level of like human effort in terms of monitoring and observing these things, right? You can't have your API gateway fail anyways. It's the same question we talked about, because then every other thing breaks in your system, right? So one of the things you can do is implement proper monitoring, right? Implement health checks as much as possible on your gateway. Implement a notification system that sort of like notifies you. And the cool thing is, these days you can integrate a lot of you can integrate it to a lot of what's it called again? Applications, for example, like Slack, like Teams. There's so many bots that could actually just pick a URL of where that data should be coming from, and you get notified via email, and as many means as you want, right? But at the end of the day, you can't totally fight off everything anyways. But then again, that's why we talked about resilience. So the whole idea is that you need to be able to put a lot of systems in place to make sure that core components of your microservices are always up and running at every point in time.
Thank you very much. So the Docker class is coming up next week too, right?
Yes, next week.
Okay, thank you.
Okay, so
All
good
right.
afternoon, everyone.
Good afternoon.
So I just wanted to
So
confirm, just so
another
that
thing that I will just point out, right, is so one of the other things you can do is have like a failover system for your gateway. So just in case it goes down automatically, it's always good to have a failover system that it can automatically call. And if that fails again, then of course you should know about it. But one of the cool things to do is just enable a failover system that if your gateway goes down, requests can be routed to other ways. Yeah.
Okay. Okay.
Yeah,
Okay.
okay. So to add, right, Patrick,
Yeah,
so can I also add something as well?
sure.
Yeah, okay. So to add to what Patrick just said, right, David. Now within the microservice architecture, right, you must have. Patrick talked about the point of, coming up with like an architecture of what it is that you want to build, right? It is very, very essential that you identify those components that are very, very critical to your services. For example,
Very critical. Yeah.
if your gateway is more like an entry to your to your to the other components,
Services.
meaning without the gateway, nothing can happen. Then of course you will have to sort of distribute the gateway itself. So let's say, for example, now you're actually running within a cluster, maybe like a Kubernetes cluster. Of course, it is not essential that you have only one replica of your gateway, of your payment gateway. You need to have like redundancy in place, even if you are not running within the Kubernetes cluster. If you are running a flat structure, right, you are not using any form of orchestrations orchestrator systems in place, such as
Yeah.
OpenShift, Docker Swarm, or Kubernetes, you should still have some form of load balancing in place, because this is like your critical. You will not want to put everything in one basket. You need to kind of like replicate the service so that even if one should go down, of course, traffic would definitely be routed intelligently to the second one without your users even identifying that something has actually gone wrong within your system itself. Do you understand? So all of those
Exactly.
critical systems, you need to identify them and cater for HA, which is high availability, as well as redundancy. And that is where the concept of disaster recovery comes into place. So if all your users, right, are actually sourcing traffic from your primary data center, what happens if that primary data center should go down? Then automatically you should have like, maybe when we get to cloud systems, we'll talk about intelligent layer 7 load balancers, that they are actually intelligent enough to say, look, my primary data center is down. I need to route traffic to the secondary data center. And they should be able to come up automatically without any manual intervention. Do you understand? That is where your software defined load balancers, which of course it's beyond the scope of this class itself. They're actually intelligent enough to know that users that are trying to maybe call the payment gateway somewhere, they are unable to call that. Then as a result of the intelligence that's been built into place, traffic is going to be routed to whatever backup I have somewhere. And it's also very important to note that if that application itself is stateless, right, then it should be able to source its data from, Patrick was talking about the event-driven system. If it's going to source the event from the event-driven system, or if it's going to source that same data from a database somewhere, then it should do that automatically. These are all of the failover systems that you would have actually built. Well, it's not the function of a DevOps person though. It's a function of the solutions architect itself to be able to build all of those things into place. So I just feel I should just add this as well.
Okay. Someone is asking. Hello. Can I talk?
Yes, please go ahead.
Yeah.
Okay. Someone is definitely asking me question in my private message, like on WhatsApp, that what he does not know the function of load balancer. Though I myself, I understand the function, which is I can explain it if you give me the go ahead, sir.
Well, someone is asking questions on your WhatsApp. You can just go ahead to just, if you have the response, you can just go ahead so that we don't take much of our time.
Okay.
Yeah, Patrick,
Okay.
go ahead, please.
Yeah, so I think I'll just even like touch that briefly. So again, Another thing you might have to do, like that explained, there are a couple of options, also, remember, we talked about all of this as a distributed architecture, right? So you could have like multiple gateways distributed across different servers and different systems. So if one goes down, your system should be smart enough. Again, that's where load balancing comes into play. And it's just very simple. It's just the way to distribute that traffic across multiple gateways, right? That's what your load balancer does. It sits in front of your gateway and distributes that information right across all of your gateways. So having a distributed architecture sort of solves your problem because your gateways too can be distributed, right? And with your load balancer in place, you can always ensure that at every point in time, traffic is evenly distributed across all the instances of your gateway running. So yeah. Any other questions?
Please, I have a question. I think I dropped it on the chat. Help differentiate between load balance and proxy, or maybe if they are the same thing. Please.
Sorry, I can't hear you.
Okay, I said help to differentiate between a proxy and a load balancer, and if they are the same thing. I'm not sure.
Oh, okay. Okay. So let me start by saying we need to first understand what a load balancer is, right? And what a proxy is. So a load balancer just focuses on a couple things, right? Distributing traffic evenly, right? Focus on scalability, health checks, right? But a proxy is more or less like request handling. It just determines where to forward a particular request to, right? A load balancer sits in front of these servers or these services and is able to receive that request from a proxy and distribute it evenly across all of the services that are requesting for it, right? But a proxy is more like a tunnel that just picks that request and forwards it to the appropriate service. Now, keep in mind that in front of that service, there's a guy who is a load balancer that takes that request and spreads it evenly across all of the services or instances. Yeah.
Okay, thank you.
Okay. So let's just briefly touch on your assignment if there are no other examples. Okay, so I have a simple example assignment here. Choose a real-world example of a microservice-based application or system. Example, e-commerce, ride-sharing, social media, and analyze how service discovery and orchestration are implemented in that system. Discuss the challenges they might have faced and the benefits achieved. So you could pick anything. Anything could be your use case. Your assignment should be typed and well structured. Use proper citations and references where necessary. So I'll make available this document on my Google Drive because I will also want you to use proper citations. You can go back to the document to refer to some of the concepts I touched about. If possible, include diagrams or examples. So I sort of, the same way it's easy for us to just do like a quick diagram here and we sort of have like a picture of what's going on. It would also be nice if we could use diagrams and examples. And then again, ensure clarity, coherence, and conciseness in your explanations. So your grading criteria will be evaluated on the following things: your clarity, depth of understanding, accuracy of information, depth of understanding demonstrated, like if you use a diagram, that makes sense, use of relevant examples, and proper formatting. So yes, this will be your assignment on microservice architecture. So I'm hoping that you guys can pick like more complex systems and try to just analyze it from your own perspective and try to put down a diagram of what you think is happening. And that will make you think a lot. And when you think about some of the concepts, you should do your research and come up with a simple paper like this. All right. So any more questions, Dapo? If not, is it right to say CMS like WordPress, Wix are example of monolith service? Reason being that they feature in a single container. Well, I mean, you could say that because you could build a single PHP application, right? That has a UI, leverages on HTML and CSS and JavaScript, and also leverages on MySQL, for example, for data storage. Maybe it's using Redis to save stuff temporarily. But yes, you can all package that as a single monolith application, right? But by default, the fact that you're already using you're already building your HTML, CSS, JavaScript, and PHP in just one project sort of qualifies it as a monolith system, because then again there are a couple considerations that could be made that can break this system into sizable chunks that will achieve what they need to do. Yes. So no, so the assignment is individual. Therefore, do we make this individual or as a team? What would be your suggestion?
Okay, so I was going to say that they can actually discuss this as a team and come up with the
Oh yeah,
documentation.
with one, yeah, that would
Yeah.
be nice.
Then on
Maybe we break
yeah,
them into a couple teams and they
yeah.
can
Then
all
on
think around that.
yes,
Yeah,
yes. Then on Friday we
come
can
up with,
just jump on the call again and just but of course they would have submitted maybe like a day before the discussion, and then
yeah,
you
so
just
we
come on the
look at it.
call. Yes. Then you
Yeah.
just come on the call and maybe address some of the corrections that you've noticed and what have you. How does that sound?
Oh yeah, so that works. That works. And it would
Oh,
be nice
Okay,
to see it'd be nice to
let's
see systems you guys pick to analyze. I'm really
exactly.
excited about seeing that.
Yes,
okay.
yes.
Please,
Yeah.
please, can I ask a question? Can we submit it on using the GitHub link, or I don't know, or should we use a
So I
Google
think
Doc?
you're breaking up.
I mean,
Come again.
can we submit the assignment with a GitHub link, or
Oh yeah,
hello?
yeah, yeah. So we're going there. Your second, so we're going to touch on. So I have an assignment for you guys on Git that will sort of involve creating a repository. So we can base off the assignment with a Git repository, maybe in a README or something. That would be so cool too. But yeah, I'm hoping to see that too. For those who want to do that, by all means. All right, so oh, sorry, my internet got cut off. So I'm asking if we take a 2 minute break and then return back to our other session, if that's fine.
Yeah, cool. By all means, we can actually do that.
Okay.
Okay, so guys, we can let us take like a 2 minutes break. If you want to stretch, you can stretch your legs, move around a little bit, and we should be back by 2:30. 2:30. All right. Thank you.
Hello?
Okay. Hi guys. Is everyone here now? Can we begin?
Yeah.
That's the guy.
Okay, awesome. Okay. Okay, so you guys let me know when you can see my screen.
You can see your screen.
Okay, awesome. So I will just rush over some of these concepts, right? I think we should just start off with talking about what version control is. Um, what is version control? Version control, also known as source control, or oh dear, so is a system that allows you to manage changes to files, documents, or any other pieces of information over time. It's commonly used in software development, but it can be applied to various domains where tracking changes and collaborating on documents or code is important. Um, so like it goes, right, is a source control system, right, that helps you to make changes to files, documents, or information over time. Is a type of system that has been developed to make sure that making changes to multiple files or documents can be done seamlessly, um, with multiple people collaborating on it, right? And having the right data or the available data on what happened throughout the life cycle of that document, as the case is. So one of the some key aspects of version control that we need to, have at the back of our minds are history tracking. So like I talked about, it makes it very easy to know what happened during the life cycle of that particular file, track the history, and it makes collaboration easy. So collaboration is having like multiple people, right, work on a particular document and not having issues with it in such a way that people can collaborate easily from anywhere and from any system. So you have branching and merging. So this is a concept in JIT that sort of involves creating branches from specific branch. So we'll get to that bit, right? And other things like reverting to previous state, conflict resolution, backup, and disaster recovery. So some of these are the key aspects of version control, and it cannot be overemphasized for us who work in tech, especially working in product teams that require you to modify code changes, work on the same code base, most times even work on the same feature, right? For example, you could say two engineers should work on a login feature, and somehow they have to come up with that whole feature as one, even though two people are working on it. So version control sort of makes all of these things possible. And not just that, it also is a key process for continuous integration and continuous deployment, especially when it comes to a microservice architecture, right? Because one of the other things around a monolith is that, well, one person can just build a monolith system for the most part, right? But if you wanted to set up a microservice architecture as a single man team, well, it will take you more time than you will even envisage. Good luck to you. It will take you a lot of all-round knowledge, right? So version control is very key, especially working with complex distributed systems. So it also help you do things like even version your APIs. So at every point in time, you know the particular version of your API that is in production or what is in development. It will help you create pre-releases. There are scenarios where maybe two guys are sharing a core library, right? And you wanted to make a change to the core library for one guy. And you're like, well, how about I create a pre-release, right? So things like version control helps you do that. So you create a pre-release and the new guy can leverage on the pre-release even when the actual guy is being used by everybody else. So this just is a no-brainer. We need it. And yeah, we will talk about JIT. So JIT is a type of source control, right? I don't know if you guys have heard of Mercurial, right? So Mercurial and what's the other guy again? I hope I can remember it. So this is another way of managing what's it called? Version control systems. So wait. Yes, so CVS. So it's called CVS, concurrent version system. So you have Mercurial, you have JIT. But for us, mostly we're used to JIT, and that's why I'm just going to base this conversation using JIT. JIT is a distributed version control system, DVCS, that helps developers track changes in their source codes or any set of files. It was created by Linus Torvalds in 2005 and is designed to be fast, flexible, and efficient. So JIT is widely used in software development, like I said, to manage and collaborate on other projects. Like I said, there are other guys you could try out using like Mercurial or CVS, concurrent version system. So it's widely used to manage and collaborate on projects, but it can also be applied to any domain where version control is needed. Again, for example, you could use JIT for your documentation, to be honest, if you needed to, implement the concept of version control in that kind of system. So it's not limited to only codes, right? The system itself can work in any place you actually need to set up a sort of version control system. And that's also very key to note. So some of the keywords, right? Repository. I touched this earlier. So a JIT repo is just a storage location for all your files and the history of a project. Think of it like a container that houses everything, right? That container is a storage location. It also houses the files, houses the history of all of the files, and literally everything that we need to know to track what happens in our repo as it is. So you always often hear people say repo, which is just a short form for repository. So a commit represents a snapshot of your repository at every particular time, every point in time. It records changes to the files and includes a commit message that describes the changes made. So one of the other important thing to note in version control systems is commit. It will always come up. So it's just a way to tell JIT, right, at a particular point in time that you made a change and JIT records this change. So a commit is a snapshot of that change you're making to that bucket at a particular time. A branch is a separate line of development within a repository. It allows you to work on new features or bug fixes independently of the main code base. Branches can later be merged back into the main branch, right? Just a minute. Oh yeah. Okay. So typically, when a JIT repo is created, right, there is always a starting point. And the starting point is called your master branch or your main branch. So this indicates where the whole system started from, the whole version control system started from. So what you will notice is that you can create branches of separate branches. Think of it like a tree that sort of leads back to the master branch, right? So a branch is a separate line of development within a repository. It's often created from another branch, but there is always a starting branch, right? And branches can be merged back into the branch that they were created of, if that makes sense, right? Again, a branch can be merged back into its parent branch. Let's say a child branch can be merged back into its parent branch, right? And then we have cloning. So cloning is just the process of creating a copy of your Git repository, including all its files, commit history, etc. So thank God for open source and Git. It's just so easy to go on a platform like GitHub, for example, and see a lot of codes and just click on the button that gives you a Git command to clone it, and you're good to go. So that is just the process of creating a copy of that Git repository, right? Yeah. So any question, guys?
Yeah, so you didn't mention about the init. You didn't talk about the init, the Git init.
Come again.
I mean, you didn't talk about the Git init.
Oh yeah, we're going there to live demonstration. So again, I'm just trying to maximize time. So we're going to go into a live demonstration where we can look at some of these commands. So I'm going to assume that a lot of us might not have Git installed, right? Do we?
Yes, we do.
So again, most of us might be using
We
Mac
do.
OS, Windows, or Linux. I have okay. So for those who don't have, let me just copy this link and drop it in the chat. Just follow through. Um, if you're using a Mac OS, sorry. If you're using a Mac OS, just give you some time to install this, and then we can go ahead. So I'm going to give us like 2 minutes just to be sure that everybody catches up. Again, I'm assuming not everybody have Git installed. And then we're going to do a live demonstration of some of these concepts. Okay, so while we're doing that, just a minute. I want to. Okay, my screen is back up. Let me know if you can see my screen.
Yeah, we
Yes.
can see us.
Okay, awesome. Okay, so I'm going to assume that we are all good, right? So I should proceed. Okay, so let's assume that we have been able to successfully install Git on our system. There are a couple ways to do that. For the Windows guys, you have to just download Git and follow the installation process. For Mac OS, you can use Homebrew to install it. Same with Linux, the package manager, you can use that to install it. Okay, cool. So the first thing we want to do is initialize a Git repo, right? And it's just as easy as doing a Git init, right? Okay. So again, right? Oh, something to note before we continue, right, is for you to start using Git, right, you need to be able to set up your global configuration. So your global configuration is just a way to let Git know who is currently making that request, the name and the email, and it will always use that to tag its commit messages, which we'll get to. So the easiest way to do that, and again, you can check if Git has been installed on your system by just doing a Git version. So this is the easiest way for you to just check. And I'm sure you guys should just run that quickly. And then you can do a Git.
Zoom your screen a bit.
Oh, yeah. My bad. Um, Thank you for pointing that out. Let me just increase my resolution. Or
You should use
it should work.
control plus.
Yes, Control plus should work. Is it better now? Okay. All right. So we can do a git config, right? And we do a global, and we do a user.name, and we open our parentheses, and let me just call this. Okay. So this command basically just tells Git to configure your global name, because every project can have its own individual configuration, right? But usually Git goes to a particular directory on your system to find a global config
Hello,
that it
bro.
uses to tag with messages. Yes.
Sorry, I have an issue. On my VS Code terminal, I'm trying to run this command you are running. It's not working. And I've installed it on my system. Do I need to do anything,
Okay.
something else, or
What's the specific error you're getting?
you said
Are you on a
it's just
Mac OS
saying
or
Git
Windows?
is not recognized. It's on the Windows system.
Oh, okay. You might have
Use,
to.
yeah.
Can you uninstall Git and install it again? So probably you didn't specify the Git binary to be used in your global path. So uninstall it and install it again. That should work.
Okay.
I think Git
Okay.
has a window has a, is it a Git bash, something like that in a Windows system.
Yeah,
It's,
but ideally it should just be added to your path. So you don't need to open up the Git bash itself. Um, and then we can do same thing. We can just do a git config and we can say email user.email and oh no, so I should not.
I'm actually using that Git bash and it's working.
Yeah,
I don't want
that
to,
will
I'll
also
go
work.
back to
But yeah, if you do your installation, it should be added to your path. So so you do this and you also just set your username for you. So I don't know if we're all at the same pace.
yes, sir.
Um, okay. All right, so I'm going to be showing us a couple commands, right? So this command git config local list sort of lists out all of your repository configuration, right? For you, so you can see the repository format version, the file mode, bare, and all of these configs are like peculiar to Git as the case is. But that typically will show you all of the configuration specific requirements for that repo, right?
Sorry, please, after the line git config system list, are we to type in credential and the other?
What do you say?
You've gone away from the place.
All right, I'm with you now.
I said you've cleared your screen, so the part is not showing again. It's just the line after where we put our email, just after that line, system list, on the
Okay, okay,
system list
okay.
line, with credential. I was saying, are we supposed to put that? Yes, system list
Oh, no,
credential.
no, you shouldn't. You
Okay,
shouldn't.
so after the email, we shouldn't do anything
No,
again.
you shouldn't. Yeah. So these are just helper functions to just show you how to look at individual configurations that your repository has, right?
Okay, thank you.
Okay, so as we move on, I will specify like changes that are peculiar to our example and changes that you should just know of the site. All right. So let's do a git config global and let's do a list. All right. So when we do a git config global list, we can see all of the configurations that exist for our global git, right? So you can see the email that you just configured. You can see the name that you configured. And then for me, right, I have an extra configuration here. Oh, okay. So forget about it. Can you hear me?
Yeah.
Okay. So for me, right, I have an extra configuration on my JIT, right? Again, disregard this. You should not see this. This is just an extra configuration. Why I have this here is sometimes you might have to access. I'm giving you guys a bit of, okay, it's not your assignment. Okay, yes, it's not your assignment. So sometimes you might have to access repositories that are private, right? And you need a sort of way to authenticate against that repository. So this extra configuration just tells JIT how to access a remote repository I have that is private, right? So again, you can see that you can add a bunch of things into your config and JIT just goes there globally to figure out what to do, however the case is. So for you guys, you should just see your user.email and user.name. So I hope we're on the same page. Any question, guys? So basically what we've done is just initializing an empty JIT repository, right? Literally. Okay.
Okay,
So
I have a little question. Now, you know, you don't have any
sure.
code written. For example, when you want to push, what are you going to push? Or you're not pushing,
What do you say?
or you're not. I mean, in your VS Code here, there's no code, there's no file, nothing else is written there. And when you want to
Nothing
like,
else. Yeah.
yes. Or do you have anything there? I can't see anything there.
Oh, no, it's empty. Literally, it's an empty repository. We're assuming that we have nothing existing, right? So what we've done is just create an empty repo. We can't commit anything. We can't do anything else. We don't even have a branch, right? Yeah. We don't have a branch. We have nothing else. It's just as empty as it is, right? Again, I did it that way specifically. So remember when we talked about a starting point, right? Usually your starting point is either your master or your main branch. So what we can do now is create a starting point for all of our actions. So we're going to create a branch called a master branch, and it's as simple as doing a git branch, and we will call it main, right? Let's call it main since we are going to be using GitHub for the most part. And on GitHub, it's called main. On Bitbucket is master, right? But usually it will always be main or master. Not invalid. Okay, master.
When you're creating like in most cases, like I thought you would create it from the repos from the GitHub UI, that's the interface. When creating your main and stuff, that's how I do my own. Like first of all, I have to create a
okay.
and that repository will carry the main branch. And what I'll do, I have to like have to add like either I'll clone it or there's another way I'll just do it to connect to my remove repository.
Yeah. So basically, if you're using a guy like GitHub, right, a bunch of things are abstracted for you. So you will not have to create a new branch. By default, it will just create a default branch for you, like you said, usually master or main, and then you can start from there. But ideally, right, what I'm trying to do is just create something very bare and empty, and we can see this work like from scratch, right? So if we check,
But I think this way
we have
is this way is good because when creating like if you don't want the most time like most code like most repository, I will see production and dev and something UIT I've forgotten, but something like that, which is or the staging branch. Yeah.
yes, the staging branch. So again, just something to explain, right? Thank you for mentioning that. So there are standards in place, right? Naming convention standards. You always come across branches like main or master, right? Then you always come across branches like develop or development. And then you always see branches like staging, right? These three names you always see across multiple repo just points to a standard of naming convention that gives you an idea of what that branch is. So a development branch will always be the branch that contains this most stable version of your project that is being developed, right? And typically, it's always the branch to just branch off on if you want to start working, right? The development branch is always that branch that will hold the latest stable version of what actually works, right? And then you have staging. Staging most times for different people could refer to a branch that holds all of the changes that are available to be tested, right? That can be tested by anybody. And then, of course, you have your master branch, which will always be the branch that has what the production environment has. Or most times, some people might specify it differently, right? But you will always see that. All right. Why is it saying this? Hold on.
I think you have to initialize it first. Okay.
Yeah, so I think we did that. Let me see. I need to be sure I'm in the right. Okay. All right. Okay, so why is it? Can someone try this command on their system?
Yes, on my terminal, it's saying not a Git repository or any of the parent repositories .git.
Oh, okay. So you have to create your
initialize.
direct.
Yes.
You have to navigate to that repository. You have to navigate.
My own is already on that main branch. If I say git branch, it will bring out that main. So if I now say git main
Okay, so you already
branch
have a
main,
main branch.
it will say fatal, not a valid object name main.
Okay, wait,
Maybe
come
you should
again.
try
What is
because
your
Yeah, I think same
experience?
thing as mine. Fatal, not a valid name.
yeah, I think normally you already have this master as the default one. So
Yes.
so you may have to maybe what you're trying to do is to change it to main. So it may now be git branch master main, like change master to main or something. I don't know.
Minus
Oh no,
M.
no. So we're going to
You
come
have to
to
use -m.
Minus M, not checkout
Okay.
or
No, checkout will not do it because you do not have another branch. So checkout will not do it.
creating the branch, you have to use a
wait. Sorry, guys. So let me take one question at a time. So I'm sure of who to respond to. All right. So what are your different experiences?
Mine is saying not a Git repository or any of the parent directories .git.
Okay, so navigate to that repository first, the folder you created.
Okay, please, what
then
command
right
do
there.
I put?
Also, what is the directory?
Sorry, what did
Okay.
you say?
Okay, so you know what? I think that we should start all over again. So you guys should follow me through. So I'm just going to assume a couple things, right? So I make sure that you guys are not on separate pages. So the first thing you should do is navigate to a directory in your system where you want your Git repository to be, right? So that's the first thing. Do that. So the next thing we are going to do is do a Git init, right? And this time around, let's call it Git 101, which is the directory I'm using. All right. So are we there now? We should see something pop like this. All right. So navigate to that directory. Let's assume you're there now. So it's an empty directory, right? All right. So we're going to do a Git branch. And we're going to call this master. All right. So if you do this, let's do a Git branch now. We can see okay. All right. So you're going to do something for me. Do this command, Git branch, Git checkout /b, and then we're going to say develop. Right.
Switch to a Git branch.
And I'm going to explain what that does. Then we do Git branch. Okay. Are we all there?
Yes.
Yes, yes.
Okay. So let's create a new file. Let's just call this a readme.md. Right. And let's see. And let's save this.
How do we do that on Git batch? What you just did now? Yes.
So we can do,
Use a
it
dash
depends on
command.
your OS, right?
You can use mkdir one.
So you can use a touch if you're on a Mac
No,
OS.
I'm
to create-
actually following you, but where you just use that readme, that's what I'm now.
Oh, okay. So you since I'm using an ID here, I just created it from here. But you can also create that from your terminal. Okay, so are we good?
Yeah, we are good.
Okay, so let's do a git add and let's do a dot, and I'll explain what all of these commands are. And let's do a git commit. Okay. Can everybody see the same output?
Yes.
Okay. So do a git status and then we can explain
my own is not showing that output.
Okay, so what's the output you're getting?
Can I just
Copy it and paste it on a group chat so that we can see.
All right. So a couple things to explain, right? So we started off by creating a master branch, right? Which is the entry point. So again, remember when we talked about branches? A branch is just a snapshot of your repository at every particular time. And it always starts with the master branch, right? So after we created a master branch, we created a develop branch, right? So this command I have here, git checkout -b develop.
Can you see the error
is
message I
more
pasted on the chat?
Yeah.
Okay, so what is your message? Auto. So you have to do a git config. You have to set up your git config first.
How do I do
So
that?
I am just going to.
I think, okay, let me send a command to you.
Yeah. So you already have it. Git already tells you what to do. Right. So this is the command. So you use the first one to set your email, and use the second one to set your, yes. Can you see it?
Your username or
Okay,
email.
Okay.
Git
I've seen
config
it.
global.
Yeah, I've seen it. Yeah, I've seen it.
Okay,
I've seen
nice.
it. I'm working on that one.
Okay. So this command git checkout -b develop.
Hi, Patrick.
Is actually,
sorry to interrupt you, please. Are you there?
yes, come again.
Please, I use the
Yes.
command git branch, and I have to I have the main and the master indicated, and I have an asterisk on the master. So I'm not sure what the situation is. Maybe I may have set it up previously, but I'm not sure what the situation is.
So the asterisk tells you the current branch you're on. So you're currently on your master branch.
Okay, so I still have the main and the master. Do you think that's
Yes.
better?
Yes. So a good example now will be, how do I move across branches, right? So you can do a checkout. Hold on. So you can do a checkout to the branch you want. And if you do a git branch, you see that you're on the master branch, right?
Okay.
So if I wanted to switch back to the develop branch, all I have to do is do a git checkout back to develop. And
so
I think there might be something wrong.
It has worked for me now.
Okay. All right, thank you.
Yes. Okay. Oh yeah, I missed the C. Hold on. Okay, so I think there might be something wrong with my config. But anyways, so you can do a git checkout between your branches. I need to be sure that's working for everyone.
When you do the git branch, normally you're supposed to show the branches as enlisted, and then you have the one asterisk to indicate that that is the current branch that you are in. But I noticed when you do git branch, it's not doing that. It's just changing it. It's not listing it.
Okay, so I was going to explain two commands for you guys, right? For creating your branches, which very key. So notice that if I do a git branch, it should tell me all my branches that are available, right? And then the asterisk tells you the current branch you're on. So if I do a git branch on a master branch, I'm creating a branch of the master branch, right? But since we already have that existing, I'm just going to check out to the develop branch. So let's check this out. Git checkout, develop, and let's do a git branch. We see that we're on the develop branch, right? So you have a command that creates a branch for you and checks out to that branch automatically. So if we do a git checkout and we do a -b and we say feature slash login, for example, right? So it tells us switch to a new branch, feature slash login. So let's do a git branch again. We can see our master, we can see our feature slash login, we can see our develop, right? So I need to be sure we're on the same page. What can you see?
I can't see to see this master. I can only see develop and feature login, feature slash login.
Oh, so you were meant to create an entry point, right? So you do that with git branch dash m and then master.
Okay, so I should do git branch now. Okay, I can see it now. But I'm on the master, so how do I switch to
so you do a
where
git
you are right
checkout.
now?
So whenever you want to switch branches, right, you do a git checkout to the branch name.
Okay, I think I'm there now.
So if I wanted to switch back to develop, and you can see switch to branch, develop. And when you do your git branch, you can see the branch on. Okay.
Yeah.
Okay, so nice. So let's say we're on the develop branch right now, and we make a change, right? And you can make a change to any file, right? Any file you have currently that you've added. And let me see, function main, just for the purpose of adding something. So you can see log, and you can add anything for yourself. Okay, so I have this hello world. All right. So I've made a change to my files, right? And currently I'm at develop branch. Now remember something key that we've touched in some of these commands, right? We've been able to create an empty git repository. We've been able to create a starting point. We created a repo that did not have a branch at all. And we were able to create a main branch, which is our master branch, or it can be called a main, with the git branch dash m and the name of the branch, right? And we've been able to create subsequent branches from the main branch. So in my example, I branched out of the master branch into develop, and I branched out feature slash login from the develop branch. And currently I'm on the develop branch. Does that make sense?
Yes,
okay, awesome. So the next thing is committing your changes. So remember what we said about a commit. A commit is just a way of letting Git know the status, the snapshot at that particular time. So to do a commit, we first need to add all of the files we need to commit, right? So you could do, you could add specific files by saying git add the name of the file, right? In this case, I made a change to main.go. So I can say git add main.go, and I'm adding that specific file, right? But if I wanted to add all of the files, let's say I made a change. Okay, I made a change to readme too. I can do a git add all. So the dot represents all. So whenever git sees a
sorry,
dot, it knows that it's just.
Can you bring your terminal up so that you can see what you're typing? It's like it's
Oh,
down.
okay.
I can't see it. Take it up to, just drag it up to something like that.
Okay. Can you see it now?
Drag it up now.
Yeah, better.
Okay. So I did a git add to add a specific file, and I can do a git add dot to add a lot of files, right? So it basically will add all of the files that are meant to be staged. So what does git do behind the scenes? it sort of keeps track of all of the files that have changed, right? As a current snapshot. And then if you wanted to add a specific file, you could tell J to just pick that file. And if you say all, it just goes to a snapshot of where it saved all the files that had been changed from their initial snapshot, and then it stages them for commit, right? So how do we commit this? We simply do a git commit, and we do a -m, which represents a message, because your commit always have to have a message, right? And then you can write a commit message. It could be anything. It should be exactly what you're trying to do, right? So in this, I can say my commit message is updated main.go. And then what does G tell us? It tells us that 2 files changed and there were 7 insertions, right? Can you see that?
Mine said
Yeah.
nothing to commit.
Yeah, you have not
Okay,
do
so make
changes.
sure you
You have not done changes
make sure
now.
you've updated something in the file, right? Because if there's nothing to commit, it means you haven't done any updates. The file is still the same way. And make sure you're
How
on
do I
the
do that?
branch that has it. Just
I have so many
um,
files. I
you just
mean,
add
different
any
PDF files.
anything to the file. Well, if you added it, if you
Okay,
added
said
a PDF
could
file,
not
you should see
open directory,
what
could not permission denied, branch develop on track files. Use git add file to include what to be
is
committed. Can I
so
quickly share my
you
screen?
remember, right? To commit a file, you have to do a git add first. So your problem is that you've not done a git add. So you have to do
I
a
did.
git add. Either you're doing a dot, and make sure you're on the directory, right, where your git repo is. So you can do a git add, the specific name of that file, or you can do a git add all to commit everything, right?
Okay.
So let's check our branch again. I want to show you something key. So let's go back to, let's check out to master, and let's switch to master branch. Okay, so you can see that on master branch, everything is empty, right? That's because all of the changes we made, let's do a git branch. All of the changes we made were on the develop branch, not master branch. So if we go back to develop, let's do a git checkout to our develop branch. We can see our changes that we added, because we added that change at that particular snapshot to the develop branch. And if we do a checkout to future/login, it's empty too, right? So I need you guys to confirm that that is the same case. So I'm going to switch back to my develop branch, which is my working branch for now. And you can see the changes. Okay, so guys, any question? Are you guys following, so I know who to help?
Okay, for me, I have a question, but it's a very technical question because I actually encounter some errors when working with Git. I think this is the best place for me to present this and look for a help, because since then I have not been able to work with that repository. I just have to abandon it, I delete it, and that's all. So when I was trying to push a large files, I was working on a project on infrastructure, and I counter when committing those changes to GitHub, immediately it was the team refused going committing, because he was saying the file is large. I should download some certain. He made some statements, so I have to download it. Install it. But I tried doing it again. Suddenly, all my files lost. I couldn't find them again till now. So, what could be the issues? And I did git rebase and the rest, but it wasn't working. So I couldn't work. So I don't know how to
So
go
yeah,
about it.
so basically, right, large files can be very so first of all, you need to know the size, right? I think for JIT, it has a default commit size of 100 MB, if I'm not mistaken. And then I think maximum repo size by default to be 1 gig, except some guys will just give you extensions. But really, I'm wondering, well, apart from if you're not a Google or something, you shouldn't be having a code base of a gig, to be honest. But then again, your commit size can vary. So if you're working with large files, it can be a problem because at some point, Git will not know what to do with the other files. So you might probably discard it. And that's why you might be having those issues with that repository. Can I ask the size of the files you were dealing with? Do you have any
No,
idea what the
it's
size was?
well, like it's very large file. I can't remember, but I'm dealing with a 3-tier application, infrastructure application. So it was giving me a headache. I can't even find the files again. I have to start all over again, writing everything. So I don't know. I don't know how you can help me to retrieve
So I
that.
think you should check out GLFS. So it's called Git Large File Storage. So I think it's a set of APIs that should provide use for you for extra additional storage beyond the default limit that Git offers you, right? So you might have to check that, but by default, you always encounter a limitation with size because again, the system was not structured to take up massive commit sizes as the case is. So you'll probably be discarding anything above a particular size limit.
Okay. What's the name of the place? DL. Sorry.
What did you say?
I mean, you mentioned DL. Yeah, I should check on the site. DL.
Oh yeah. So Git large file storage. Git
Okay.
LFS, large file storage.
Okay, thank you.
So it's a service that has just been put in place to help you with running using really large files in your Git.
All right, thank you.
Okay. So
I'm
just
still
to touch
having issues. I'm still having issues committing files. Can you tell?
What's your issue?
It's nothing to commit, so I don't
I'm trying
know.
to
Maybe
go on the same page so that I can move on to a couple things. So what's your issue?
it's just telling me nothing to commit.
Okay. So again, I'm going to ask a couple questions. Are you sure you're on the right directory? First of
Yes,
all.
I'm on the develop. As you are doing it, I'm following you. But where I had issue was when you use that main.go. Does it mean that main.go has to is only peculiar to your own system?
Okay, so let me go back
to your
again.
own directory?
Okay, so work with me, right? So you can create a new file. Let's just do touch. That's if you're using a Mac OS. Let's just call this file server. I'm just going to create a regular text file .txt, right? So I have
So
a
you are in the
new
master.
text.
Yes, should I switch to the master?
I'm on the
And do it
develop
there.
branch. Still on the develop branch.
Develop. Okay,
Yes.
that's where I am. Okay.
Okay. So
we should touch
let's
server.
make a change.
Server.txt.
I made a change. So let's just make a random change there.
Okay. Git branch.
Okay, so are we good? So let me show you something. So one of the other things
Can you
you
go up?
notice
Can
is
you take your screen up? Can you clear your screen? Sorry.
okay. So
okay.
Notice that I made that new change, right? Correct. Yeah. But because I did not switch because I have not committed that change, I can
Okay.
switch to another branch, right?
Okay. Okay.
Because I have not committed that change. So I can
Okay.
switch back to develop again.
Okay.
And sorry, check out. So I'm back on my develop branch, right? Now, let me commit this change. Okay, so this is what I need you to do next. So I'm just going to do a git add server.txt. Make sure to be in that directory, right?
Hold on.
And or you can do a dot to add everything in the directory.
Okay, done. So I'm with you now.
So the commit message, git commit, and I'll just add your commit message could be anything. So I'll just say added server dot. Again, we'll have a class where we deep dive into writing proper commit messages, right? And there's also a standard for it. But for now, let's just say added server.txt. Okay, so you should be able to see the changes that happen. So Git tells me one file change, one session.
That's what it's telling me too. Yeah, I'm good now. I'm good. Thanks.
Okay, switch to your master and you shouldn't see those changes in your master. Okay. Are we good?
Yeah, so
let's check out to them. Okay. All right. So what we're going to do now is we're going to merge our codes to our master branch. Right. So we're currently on the develop, and merging your code simply means I want to take my change from the develop branch, right, to a master branch. Does that make sense? So all you have to do, stay on the branch that has your current changes. So make sure you're on the develop branch, and I can say git merge master. All right.
Already up to date.
Sorry. Okay, so you have to go to your master branch, right? Check out to your master branch, and then you do a git branch to your develop branch. So do a git checkout master. Right, are you there? And then do a git merge develop. Git merge develop or the name of the branch, right?
Okay. Updating, blah, 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 fast forward document, blah, blah. One file changed.
Okay, can I ask a question,
Okay.
please? Are you matching to the development branch, or you're matching to the to the master branch?
Okay, so you're merging from the develop branch into the master branch.
Okay. So, but I saw you writing, you write a command here, git merge develop. So I'm kind of confused. I was thinking you're going to write git merge.
Oh, okay,
master.
okay. So the first thing you have to do is be on the branch you want to merge into. So you have to check out to your master branch. So I'm currently on the master branch and I want to merge develop into the master branch. So I do a git merge develop.
Okay, I got this stuff now.
And then if I go back to the master branch now, right? So you do a git check. So you're already on the master branch. You can see the changes. So let's switch our branches and let's see. So check out to your, because I have 3 branches here. Let me just list all my branches. So let me check out to future/login. It's empty, right? Okay. Or it's, yeah. It doesn't even have the server.txt. Let's check out to our develop. Right. So we can see our changes. And remember, we just did a merge from develop to master. So let's check out to our master. and then we can see all of the updates on the master branch too. Does that make sense? And I hope this is the case for everybody.
Yes.
No.
Okay, is that fine?
Somebody said no.
Someone said no.
Okay. But for the most part, are we all good? Just to be sure that I'm speaking to a specific issue.
Yeah.
Okay. So I will introduce a file called gitignore. So you can just do a touch. So let's do a touch dot. So it always starts with a dot. Gitignore.
Inside, can you clear your screen?
Right.
Inside master or
Yeah, so let me just clear. So let's create a new file called gitignore. I'll explain what this does.
Sorry, please, in which of the branch?
You'll be working on your dev branch, not the master branch.
Okay. Are you guys here?
Yeah.
Yeah, we're still here.
Okay, so create a new file called .gitignore. So what this file does is, basically, this file just defines.
Yes, sir.
Let's say we have a new file, right? And I'm going to create a new file. I'm going to create a new text file called, let me just call it, let's call it ignore, let's just say ignored file. You can call it anything, .txt. So what the gitignore does is a file that tells Git to ignore certain components in your code. Now, there are certain things that you don't want to commit to your repository, to a branch, but you actually just want it there, and Git should never keep track of it. So what the gitignore does is that it holds all the files that you want Git to ignore and not track. So they will always only exist on that local machine. And anytime Git is doing a commit, it will ignore it. It won't track the changes. So in the file, you now specify the file that you want to be ignored. In this case, I want to ignore ignored file .txt. Right.
Okay.
It could be a directory, right? So let me create a new directory called ignore.
Sorry, could you take that explanation again of the essence of gitignore?
Okay, so the gitignore is very key, right? This file sort of tells Git everything to ignore and not track, right? So what that means is that anything you specify here, Git will not track it. It won't even commit it for any reason. It will just exist as if it doesn't exist in Git. So you could either do a particular file. If you want to ignore a directory, you just type in the directory name, -ignore. So it knows that's a directory it should ignore, right? And you could also do something.
Sorry. Must you include that dash
Yes,
in the
please.
Sorry.
I'm with
Must you include the is it the slash in the
Yes.
okay,
Yes. So it knows it's a directory. Yes.
okay.
So you could also do something like ignore a specific type of file. So you could tell Git with the asterisk sign, and you could do something like ignore every file that starts with HTML. Right. So what this will do is that it will ignore every file that has this extension called HTML. Does that make sense?
Yes.
Okay. Okay, nice.
What
Okay.
is strange to me, what is I'm not getting is because you are using VS Code to. Anyway, maybe I will need to configure my Git to connect to my VS Code.
Oh, okay. So you could open a terminal in VS Code, or you could actually just use a terminal outside VS Code, as long as you're on that directory, should work. The reason I'm just using the terminal here, so it's easy to sort of see everything at once. So guys, give me a minute. I'll be right back.
Okay.
Just a minute. All right. So are we there? Can you guys hear me?
Oh yeah.
Yes, we can hear
Okay,
you.
nice. Okay, so we spoke about three things, just to recap. You could ignore specific files, you could ignore a directory, and you could ignore a set of files, right, that has a particular extension. So let's check this out. So let me see the branch I'm on. Master branch, right? And we made this change to our master branch. Does that make sense? Now,
Yes.
let's do a git add. And this time around, I'm going to do a git add all. So let me even see all the files git to stage to add. Okay, so let's do a git add all, and let's do a commit. So you can put any commit message. I'll just say added a bunch of files, and I hit enter. So something to note here that is very key is, even though we added a directory, right, and we added another file called ignoredfile.txt, you can see that Git is only tracking one file. It says one file change, right? And it says create mode, Git ignore. So you can see that in our commit, the only file it tracked was the Git ignore, which he added to the repository. And then he ignored these other files and directories that we created. Does that make sense?
Yeah.
So it should be the same thing for you. If you see more than one file, then you know your git ignore did not work. All right. So let's check out to our develop rather. All right. So you can see that on our develop, we do not have our changes from our master branch, right?
Well, it's telling me two files changed. Does it mean?
What do you say?
My own told me two file changed. 0 insertion, 0 deletion.
Maybe if you check, there might be a spelling error because I had the same issue and it's because of a spelling error.
Okay, so just make sure you have your, and make sure you're on the right branch too. And then make sure you have the right file. Okay, so we switch back to our develop branch. And our git ignore doesn't exist, right? Because we made that change on our
Okay,
master
sorry.
branch.
What happened was that, sorry, I wrote first the first command. I said touch git ignore. Then the second one I said touch git ignore file.txt. Probably it has created it twice or something.
Oh, okay, okay. Okay. So I guess you're on the same page with us, right?
Yes, please.
Okay, nice. Okay. So I made that change on the master branch to show us a typical example we might experience, right? So the develop branch is a child branch of the master branch. And we made a change on the master branch. But then how do we get the child branch to see that change that was made on the master branch, right? So we use the rebase command, right? So it's as simple as doing a git rebase master, the name of the branch we want to rebase. So rebase is a simple way to tell Git to move your commit and move your snapshot to the snapshot of a parent branch, right? So it basically moves all the commits from one branch to another, typically from a child branch to a parent branch. So if I do a git rebase master, I can now see my git ignore file on my develop.
Lisa, explain it again. Sorry, I missed something, so I couldn't get it up.
Should I come back again on that? I hope everybody got that.
Come back again, please. I think I have to.
Okay. So so let me check out my master branch and let me start from there. So let's clear this. So I created a file, right? Let me create a new file on my master branch. So we're on the master branch, right? And let me create a new file. Let me create it in the base directory. Let me just call it new file dot go. Let me just create a new file. Okay, so I'm trying to show you a concept. So the concept of merging is very simple. Merging is taking a change you've done from a child branch to a parent branch. So you have to merge that change into the parent branch. And we had an example where we were on the develop branch and we made a bunch of changes and then we switched to our master branch and merged those changes in, right? So that makes sense. So let's say we're on the parent branch now. And I'm trying to show you an example of how to move a change on a parent branch to a child branch. Now, I've created a new file called newfile.go, and I'm on the parent branch. So let me just commit these changes. So I do a git add first. I'm going to do a git add all, and then I'm going to do a git commit, and I'm going to say added new file. So hold on, let me move this guy. Guys, sorry, I hope I'm not taking your time because I feel like we still have a couple things to cover. Dako, I hope you don't mind.
Yeah, okay, so we might want to maybe convert that to an assignment so that we can round up maybe like in another
Oh,
10
okay.
15 minutes.
Okay,
Yeah.
but I just want to touch a couple more key components. You know, since it's an all-hands session,
Yeah,
there's something to just touch.
Okay,
Yeah.
okay.
So
All
I'll
right.
just one more time. I'll round up soon.
Okay, all right.
Okay. So let's do a git commit. We're on the master branch, remember, right? So I can now see that, oh, I've added a change called new file, right? So it's saying it created a new file. So let's check out to this to the child branch. So let's do a git checkout, develop. Now we can see that we don't have this new file. You can see showing red. We don't have it on this branch, so we can't find it. So the easiest way to get a child branch to see the changes of the parent branch is just doing a git rebase. So make sure you're on the child branch or on the branch you want to rebase against. We're on the develop branch, so we can do a git rebase, right? Rebase, and then we do master, and then let's hit enter. So you can see that it now
Okay.
gets new file to our develop branch. So we've looked
Okay.
at two scenarios, right? We started off by creating an empty repository. Let me walk you guys through this demo. And I hope you guys are keeping track of this command because this is just a simple end-to-end process of using Git. So we started off by creating a new branch, a new repo with the Git in it. We were able to create a master branch with the Git branch -m and then the master. And then we were able to create branches of that master branch by saying, by being on the master branch and creating a new branch, or with the shortcut command, git checkout -b and the name of the branch, new branch, for example. Okay. Then the next thing we did was make changes to our child branch and merge it to our master branch. So it's a simple way of taking your changes from your child branch to your parent branch. And then we did a demo of moving a change from your parent branch to your child branch, which the rebase helps you do. Does that make sense?
Yeah.
Yes.
Okay. So in a yes.
Okay. So
Please
I have
go
a question.
ahead.
How do I identify which of the branches is my parent's branch and which is the child branch?
Well, when you have
Um,
let me explain to him. For example, now, if you're working with a dev branch, which is mostly likely in the future, like your real-time organization, you'll be working with a development branch. You won't go and work with the staging branch or the production branch. Let me use that word. The production branch is likely like your master branch or your, in terms of GitHub, main branch. So mostly you'll be working with the dev branch, and if you can do Git checkout, development, you can do Git checkout master, depending on how you name it. Like you can use development, you can use master, you can use staging, because I think there are 3 branches. In a real-time scenario, you'll be working with 3 branches. I don't know whether you understand or.
So yeah, good answer. So just to expatiate on what he said too, they are standards, right? And like I mentioned, the entry point is always your master or your main branch. And then your current development branch will always be called develop or development. And then I mentioned the staging branch, right? Which basically will hold changes that can be tested. So every other branch outside must originate from a parent branch. Now, the good news is that if you do a Git log, and I want to point out something very key. So you should do a Git log on your end. So this should show you all of the commits you've made, right? Can everybody see the same thing?
Yeah.
Okay.
Yes.
So you should see where you did your merge, right? You see a thing like head, and you see an arrow pointing somewhere, and then you see another branch. Yes. So this guy simply shows you your head will always refer to the active branch you're currently on, right? Where that branch is. So the head of this branch is at develop. And then it shows you where that guy branched off from, which is what? Master branch, and where that guy went into. So you can always see. And again, this is very key, right? Because your assignment is really cool, right? And I try to explain it as much as possible. When you're resolving merge conflicts, because it's something that you experience. So merge conflict is a scenario where 2 or more people, right, make the same change to the exact same line of code on the same file. So at that point, Git is always confused. It's like, well, 3 people told me I have 3 things from 3 different people, right? But we need to reconcile it into one. There is a conflict. Which one should I take? Should I take the one from A or B or C? So you always run into issues when multiple guys are trying to edit the same thing on the same line of code on the same file. And at that point, Git is confused. So you go into a merge conflict. And merge conflicts are always resolved manually. So JIT needs you to tell it exactly the change you want it to adopt, right? Whether the change from the head or the change from the remote or the change from another branch, which you will get to see. So I tried to also a bit of insight into your assignment. I tried to break it down into different steps on how you can achieve a merge conflict and how you should resolve that merge conflict. Okay. Yes. So again, I just want to be sure we're on the same page. Any questions again? Okay. So let me do something real quick, right? Let me go to so let me share my screen and let me try to create a public repository. Okay, let me know when you guys can see my screen. So I'm on GitHub.
We can see
So okay, so I'm sure GitHub bears no repetition anyway. So you can have a free GitHub account where you can manage your repositories remotely. So GitHub is a platform built on top of JIT to help you manage your repositories remotely. So I'm going to just go and create I have an account, so feel free to sign up if you don't have one. And I'm going to call this JIT 101, right? So I'm creating a new repository online. Basically, what this what this item is doing is just doing a JIT init, just like we did, right? And then you can add a description. You can make it public or private. So a private repository means that only people you invite, right, will have access to it. Public means anyone can accept it. So again, you see extra configurations here. You can add a README, you can add a JIT ignore, you can add a license when you create it. But basically, all of these things it's doing still revolves around these simple commands we wrote to create a new file, to add a new file, to add a JIT ignore, etc. So I'm just going to ignore all of these things. I'm just going to make it an empty repository. So you can add a description. Let me just do this. So I'm going to create an empty repository. All right, cool. So now this setup, right? I want to show us how to take our codes from our local system to a remote repository, right? And two things to note about this example. We already have an existing GitHub repo on our local machine. And we just created a new GitHub repo remotely, right? And we want to be able to move our codes to our remote repository. So again, of course, GitHub is so kind to show you some simple commands. What it tells you here is create a new file, you add a new file, and you do a commit, and you branch out to your main, which we've already done, right? By creating our new. So I'm going to move this repository remotely. And it's as simple as telling JIT where the origin of that repository is. So GitHub or any of the platforms will provide you a link to your remote repository. So I'm just going to copy that. And then I'm going to do a command that says JIT remote. So I'm going to do JIT remote add origin, and I'm going to paste that URL. Again, like I said, GitHub is so kind to provide you that, that code. So if I do this, I now add an origin to it. And then I can do a git push.
We can't see your screen.
Your
screen where you're typing your command. We can't see it.
Yeah, sorry guys.
You can share your whole screen so that we can.
Let me share the whole screen. I forgot.
Actually following
Okay, let me know when you can see the whole screen.
Yeah, we can see.
Yes, you can see now.
So, the funny thing is that I had an outline that in my head when I was coming up with this talk, I was like, oh, we'll talk about this for 10 minutes, talk about this for 15 minutes. I'm like, well, I could keep these guys all day talking about this thing, but yeah, I'm almost done. So the last thing I want to show is just simply taking your codes remotely. So like I said, Git is so kind to provide us with the URL. So I will just do a git remote add origin, and then, so I already added it. So it tells me, what's it called? It already exists.
Yeah,
So I am
but
going to
mine just
do,
went straight.
yeah, because I already created it. So if you send it again, it should show you that error. So I'm going to do a git push, and then I'm going to do set upstream origin master. So you do a git push dash set upstream. So so this is meant to be. Oh, did you guys create oh, well, for those guys who have a GitHub account, you can just go ahead and create a public repository, right? And you should be good. I don't want to sign in here. Yeah. So is that repository private or
But
public?
it's saying we should sign into GitHub.
Yes. Hold on. Just a minute. Okay. Let's see. Okay, let's use this.
Minus you, yeah.
Okay. So do a git push dash u origin master.
Okay.
But yeah, I think some of the issues we have is that with, let me try something with GitHub. Okay, so we're safe. Okay. Why is it asking me to sign in? I don't want to sign in. Did I create it as a public repository?
Well, the thing is that I'm already even signed in on the system. So why is it asking somebody to sign?
Okay. So maybe, are you using GitHub?
I'm on GitHub.
So okay. So let's try this again.
It's needing us to add the key, SSH key.
Okay. I don't want to sign in.
I think you should try creating the main branch here, then before pushing to the main.
So let's see if it's from our main branch here. So let's do main. Okay, so if our main already exists, all right, so that should work. Okay, so let's try setting our upstream first. Give me a minute. Origin main. Let's see. So it still asks me to authenticate. I hope they haven't made an update. So for the
But I think
guys
it's
who created their repository, right?
signing. Won't you not to create an SSH key?
Oh no, so you should.
The system.
You shouldn't ideally, right? But even me, I have it set up, so I shouldn't be having the same issues. But so again, you can sign in using so there are two ways you could sign in, right? You could sign in using SSH or you could sign in using HTTPS. So that means if you have to sign in using HTTPS, you have to set up a personal access token that you can now configure on your JIT global, right? Again, for the sake of time, I'm going to do this. Create, okay. So I have a task that says create a Git repository on a platform of your choice, GitHub, GitLab, or Bitbucket, or you can use a local repository and initialize it with a couple files, just the way we've looked at. So create a branch, and then what you should do here is, give me a minute. Let me see. Okay. So I think what JIT is going to be asking us to do is, let me just copy this before we go.
But I've been able to sign in and all that. So,
or you can pull the code, sir. You can pull it from
Yes.
the
So that's what I'm.
Yeah.
Do I? So let's attempt to pull the code. All right.
So I can see it now.
So you guys should do a JIT clone, right? So here's another trick. So do a JIT clone. So copy the URL to your repository, right? Copy the URL to the repository. So that way, if we clone it, GitHub should not ask us to authenticate. So we're going to clone it first. You can clone it to a new directory. So let me just open a new window. So I cloned that to my desktop, Git 101, and it's empty. Again, it's because of the conflicting branch name. So GitHub will expect you to have a main and not master. So I'm just going to trust, and then I'm going to do a Git branch, and it's on the main branch. All right, cool. So what we're going to do now is that I'm going to go to my directory, and I'm just going to go to my Git 101, and I'm just going to copy everything except the .git. So if you notice, JIT always creates a folder in your root directory called .git, where it's able to track everything that happens in that repository. So ignore that guy, don't copy it. So I'm just going to copy all of my changes.
How can I see that directory from my system, from my local?
Oh, okay. So it's hidden. But I know for Mac users, you can do a Command Shift dot to hide and unhide. So Command Shift dot will hide and unhide any hidden folder.
In my C drive?
No, in the repository itself, in the repository. So I'm trying to copy everything in the repository to the new guy we cloned, right? So I'm just going to go to my desktop.
Can you show me the command again? That clone command. Where is it?
Okay, so you just do a JIT clone. See it here. So I'm just going to clear this. So it's a JIT clone, then the URL you're trying to clone from, which is the URL I created. Yes.
Okay.
All right. So I just copied those files into the remote repository we created. So apparently, GitHub will not let us do that because of conflicting branches. So I cloned the repo I created online, which is this guy, right? So I am going to now commit my changes. So I'm going to do a git add all git commit moved changes from my local machine to remote repository. Right. So it shows me all of the changes. Okay, so this is a good example, guys. Now, let me show you something very, very cool before I go, right? So you can see that by default, most times when you copy files into other directories, your Mac OS adds this hidden file called .ds store, right? So we have a situation where we have a file that was added to our commit that we don't want to be in that commit called ds. So how do we remove this file? So we can do a git remove, git rm, and then we do ds store, ds store. So it tells you that I removed it. So git rm, right, will remove a particular file. If you wanted to remove a folder, so you will do a git rm and then you do a r, which specify recursive. So you git remove recursive, then the name of the folder, if the folder was called folder, right? So what we've done is that we've removed the file that we don't want in our commit. And then all we have to do is add another commit. So we do a git add and we do a git commit and we say removed.ds store. So you can see now one file change, delete mode.ds store. So it has removed that from our commit. So this is a good example of a situation where you find yourself where you've made a commit and you want to remove a certain file in your commit. All you have to do is just do a git rm and then the name of the file. Make sure you're in the directory where that file is meant to be and do a git remove. Or if you wanted to remove a folder, you do a git rm -r, which means recursive. So you delete the whole folder. So we can now do git push as you origin main. Okay, so why is this still happening? Okay, so I think, so you guys try this and let me know for the guys who have a remote repository. So I think I might have some conflicting issues with Bitbucket. I don't want to change my setup. Currently, my setup is set to use Bitbucket instead of GitHub. So I won't want to modify my setup, but you guys should try this. That should work. So I'm waiting. Can I have someone who has done it?
Who has done what? The cloning.
Yeah, so do I have anybody who has created an online a remote repository? And
Yes,
I'm asking if you
I've
can
done that.
push to your GitHub.
I've done
Okay. But first of all, right, again, I don't want to change my setup, right? You have to be logged in into into GitHub with your personal account anyways. So let's see.
Can I show you what I have? Maybe
Yeah,
I'm
share
on
your
the right
screen.
track or
Let
something.
me use it. Yeah.
Okay, I can't share screen.
Oh, yeah. Dapo, how do I get
Can't share
someone
screen.
else to
It's good.
So Patrick, I think at this point we may need to just round up so that we can, yeah. I think Lawrence. Okay, so Lawrence, maybe if you have any
Let me
issue with
just
us,
yeah, I'm good, Sha.
definitely
I'm good.
would have exactly, because we have
Yeah, I'm
actually
good.
spent a lot of time
Oh,
on
yeah. Oh, I
discussion
forgot
with
that this
you.
is after 4 o'clock.
Yeah.
Sorry, guys.
I'm hungry, chef.
Oh, dear.
Okay, so Patrick, we can just round up, right?
Yes, let me
Or do
share.
you? Okay.
Let me
Or
share
do
the
you?
link to
Okay.
the assignment.
Oh, okay.
That's let me share a link to the assignment. So I will just update everything on that document for both assignments. And that should carry a step-by-step process of what to do for everyone. Sorry.
But are you almost done with the class?
Are we going to have a follow-up on some of these conversations?
What did you say?
Are we going to have a follow-up on some of these topics, like a part 2 to them?
Yes, we can actually have that. Okay, so let me just follow up with you after now so that I can know your schedule, maybe during the week, and we can just have maybe like a sort of like a follow-up class now, right?
Yeah.
Is that possible?
Yeah, absolutely.
Yeah, because
Yeah,
we might not be able to
definitely.
cover everything. We might not be able to cover everything, you know,
Yeah.
today.
Well, again, for the most part, we've covered the key concepts, but there are a lot of other things I would have loved to show them. Unfortunately, we
Okay.
don't have time. So if
Can
we
I have
can
a
have like a 1 hour follow-up session, I
Yes,
will.
yes. Okay, so after now, we'll just discuss so that if it's going to be during the week, we can know the time and just communicate to all the mentees.
Okay, makes sense. But yeah, the links to the assignments also here.
I think it will be drop in the group, like Discord group.
Yes, I will drop it. I will drop it on our Discord. I will drop it on the Discord group. So, Patrick, I will also add you to the Discord group. So that's more like a platform for dissemination of information. So I'll add you to the Discord group as well, so that we can have another day this coming week for us to just finish the class.
Okay. All right. So I've updated the document with both what's it called? Assignments. So I'm hoping to get a lot of feedback on the group. So message me. Hopefully this week I should have a lot of time to attend to some of these messages. So I'll be looking forward to it. I will also I will do a list of all of the commands I wrote on this sheet, just so it's helpful for you guys too. So since we have a document, we can always update it. So I will be updating the list of all the commands I used in this demo for you guys to practice through. And I'll make it step by step from initializing to committing and the rest. So that will also be helpful. Yeah, so you can replicate the examples yourself for those who didn't get it.
Okay, all right. Yes, thank you so much, Patrick. It's been a very, very fantastic session. Thank you so much. So the next thing is I would add you to the Discord channel, right? So that we can come up with another session this coming week. If it's going to be maybe like on a Wednesday or a Thursday, most likely it's going to be in the evening. We can just set up a call for that, right? But if it's not going to be convenient, then we'll just have to look for another makeup class, just to cover the other concept. Because the truth of the matter is, all of these concepts are very, very important, and these are what you're going to be using on a daily basis, even as a DevOps practitioner. If you are working, just within your DevOps team. If you need to commit, maybe like a Helm chart or your Terraform infrastructure as code files, your Ansible files, and all. Like, how are you able to, not have conflicts, in a team? So this concept is very, very important, and that's why I don't want us to rush it. We need to understand the concept very, very well. Do you understand? So that you are not just copying and pasting on your PC. You're not just copying code copying infrastructure as code files from your system and just sending it across. Do you understand? So you can also branch out make a commit, push to a particular branch where you want to collaborate with another person, and the flow just continues. But you need to understand these concepts very, very well. And Patrick has been able to, he has been able to do justice to that, but it doesn't stop here. It doesn't stop here. Okay. So
Yes.
thank you so much. Yeah.
Can
Please,
you? So yeah. So just to add a couple.
link.
Okay. So just to add a couple things to what Dapo was saying, sorry guys. So I think I should even give you guys a bit of an idea into some of the other concepts that we couldn't cover that I would like us to cover. And for example, JIT tags, like he mentioned, committing your changes if you were working like with a team, and then there is need to version these changes so that at every point in time you know the exact version. So we'll talk about JIT tags, we'll talk about submodules, we'll talk about JIT hooks, and then we'll talk about JIT workflows. So hopefully in our next session we should be to be honest, we've majorly covered the basics, but there are also other key things that you will need to work with. So if you want to read more on it ahead of time, read up on JIT tags, JIT submodules, JIT hooks, and JIT workflows. So those are the 4 things we'll cover majorly, and then the other ones will just be to-dos and not to-dos. Yeah.
Okay. All right. Thank you so much, Patrick. Thank you so very much for your time. I was thinking that this was going to be covered in like an hour, 30 minutes to hours. I didn't know that we still have a lot of work to do. So yeah. Okay, so thank you so much, everybody. We're going to reach out on Discord. So don't worry about the assignments. We are going to consolidate all of this and send on the Discord page. So it just shows that we have a lot of work to do this coming week, right, ahead of the presentation for Friday. And also the class for Saturday is going to be basic introduction to Docker. So whatever it is that we're doing on Docker is a build up from all of the classes that we've had thus far: Linux, version control, microservices, right? So please, let's take all of these classes very, very seriously. And we're also going